Exercise 7.3, first question. Triangle ABC and triangle DBC are two isosceles triangles. Two isosceles triangles on the same base BC. Triangle ABC and triangle DBC are two triangles on the same base BC, and vertices A and D are on the same side of ABC. If AD is extended to intersect BC at P, you have to prove these three. Triangle AB, these four, triangle ABD congruent to triangle ACD, triangle ABP congruent to triangle ACP, AP bisect angle A as well as angle D, AP is the perpendicular bisector of BC. So we have to take one by one. The first one given is, what is given actually? First we have to write what is given and what to prove. Given. What is given? Given triangle ABC is an isosceles triangle. So AB is equal to AC. Next one, triangle BDC is an isosceles triangle. So what is given is BD equal to CD. What to prove? We have to prove all these four, which you have to write. To prove first one, second one, third one and fourth one. So we are taking one by one. The first one is triangle ABD. Triangle ABD is congruent to triangle ACD. From here itself we can identify which congruence criterion we should use. What is given? These two sides are equal and these two sides are equal. What about this side? The side is common to both. So we have to use SSS criterion. So what is given? AB is equal to AC is given. BD is equal to CD is also given. And AD is equal to AD is common. So what we can say? Triangle ABD is congruent to triangle ACD using SSS criterion. So these two are congruent using SSS criterion. Next triangle we should prove. What's the next one? Triangle ABP, full triangle ABP is congruent to ACP. So what you can take here? ABP and ACP. So this side is common. And already AB is given equal to AC. So second one. AB is equal to AC is given. What about this side? This side AP is common to both. So we can write AP is equal to AP common. So what is the next one which we need? We need either an angle or a side. The third side is BP and CP. Can we say it is equal? No. So we have to go for one of the angle. So what we have done is we have proved these two are equal and this side is common. So which is the angle between these two? These two are the angles. Can you say these two angles are equal? Yes. How? Using this. We have already proved triangle ABP is congruent to triangle ACP. So these two are congruent means these two angles are equal using CPCT. So we can prove the included angles are equal. So Angle BAP is equal to angle CAP using CPCT in first one. What is the CPCT? We have already proved these two triangles are congruent. So, if these two triangles are congruent, we can say each of the corresponding angles are equal. So, these two angles are equal. So, what we can say? Triangle ABP is congruent to triangle ACP using which criterion? SAS criterion. Then third step, AP bisect angle A as well as angle D. See, AP bisect angle A means AP divides angle A as two equal parts. AP divides angle A as two equal parts. How? This is the reason. Angle BAP is equal to angle CAP using CPCT in 1. So, we can say AP bisect the total angle A. Third one, first part is angle BAP is equal to angle CAP using CPCT in 1. So, what we can say? Implies that AP bisect angle A. AP bisects angle A. Then we have to prove AP bisects angle D. For this, you have to consider these two triangles. Consider these two triangles. This is angle D. We have to prove that angle AP bisect angle D also. For this, you have to consider triangle BDP and triangle CDP. Consider triangle BDP and triangle CDP. Triangle BDP and CDP. Can you say the corresponding parts in that? Which is the first corresponding part? These two are equal, isn't it? Then which is the next corresponding parts? DP is common in both these. What about the last one? Last one is, we have already proved APB, triangle APB is congruent to ACP. This means that these two are equal using CPCT. We have proved that using this. Triangle ABP is congruent to triangle ACP. So, these two sides are equal using CPCT. The first one which we can write easily is BD is equal to CD is given. BD equal to CD is given. Which is the next one? DP is equal to DP common. DP is equal to DP common. And the third one, what we can say is, these two are equal. BP is equal to CP using CPCT in 2. BP is equal to CP using CPCT in second subdivision. So, what we can say, triangle BDP is congruent to triangle CDP using SSS criterion. If these two are congruent, we can say these two angles are equal using CPCT. What we proved is these two triangles congruent. If these two triangles congruent, we can say these two angles are equal using CPCT, or we can say AP bisect angle A also. Therefore, angle BDP angle BDP is equal to angle CDP using CPCT in this. So, these two are equal means what we can say? We can say AP bisect angle D. We can say AP bisect angle D. Then last one is AP is the perpendicular bisector of BC. AP is the perpendicular bisector of BC means AP divides BC into two equal parts and the angle here is 90 degree. So, we have already proved these two triangles are congruent. So, that means BP is equal to PC, or we have from the first one also, from the second one also we can conclude that BP is equal to CP. So, fourth one, BP is equal to CP using CPCT in 2. Then what we have to prove? These two angles are equal. We have to prove these two angles are equal to 90 degree. But these two angles are equal because triangle BDP is congruent to triangle CDP. Since triangle BDP is congruent to triangle CDP, angle BPD is equal to angle CPD. Equation 1. But what about the sum of these two? Is 180 degree using linear pair axiom. But angle BDP plus angle CPD is equal to 180 degree. Equation 2 using linear pair axiom. From these two what we can conclude? Angle BPD is equal to angle CPD is equal to 90 degree. So, what we can say? AP is the perpendicular bisector of BC. Then second question, AD is an altitude of an isosceles triangle ABC in which AB is equal to AC. We have to prove AD bisects BC. AD bisects BC means BD is equal to CD, and AD bisects angle A means these two angles are equal. So, we can start. What is given is AB is equal to AC and AD is the altitude. What do you mean by altitude? Altitude is the perpendicular from the vertex to the opposite side. So, I have marked this as 90 degree because it is an altitude. So, what to prove? AD bisects BC and AD bisects angle A. So, for this consider these two triangles, triangle ADB and triangle ADC. Triangle ADB and triangle ADC. Can you prove the congruence? So, consider triangle ADB and triangle ADC. So, what is given? AB is equal to AC is given. AB is equal to AC is given and one angle 90. Angle BDA is equal to angle CDA is equal to 90 degree. That is also given. What is the one side? So, this is 90. So, this is 90 and this is the hypotenuse. So, that is also equal. So, we need one more side. Which is the side? AD is the common side of these two. So, what we can write as AD is equal to AD common. So, what we can say? Triangle ADB triangle ADB is congruent to triangle ADC using RHS criterion. So, one angle 90, hypotenuse equal and one of the side also equal. So, we can say these two triangles are congruent using RHS criterion. If these two are congruent, what we can say? What we can say is BD is equal to CD, that means AD by 6 BC, and these two angles are equal using CPCT, that means AD by 6 angle A. Therefore, BD is equal to CD using CPCT. This means that AD by 6 BC. AD by 6 BC. Second one, angle BAD. Angle BAD is equal to angle CAD using CPCT. This means that AD bisect angle A also.